Okay, so the first thing that you need to do in this question is to separate the triangles out from your 3D diagram. So we know that A is the top of the mast. Just have a little look at the question again. Okay, so A is the top of a mast, B is the base, and B, C, and D are all points on level ground. So we have a right angle triangle at ABC and also another right angle triangle at ABD. Our third triangle is, looking from a bird's eye view, is the triangle BDC. Now the question also tells you that D is 400 meters due east of C and that B is due north of C. So when you draw that up, you should get this third triangle, and you should have a right angle because B was north and D was east. Alright, now we also know that AB is where the height of the mast is. So our task is to show that expression for H, just up here. So that's what we're going to do. So the question gives you a little bit of a hint. It's using cot 10 degrees and cot 12 degrees. So we know that we're using the first two triangles here with a 12 degrees and a 10 degrees. Cot is the reciprocal of tan. So we're going to start by getting an expression for BC, because this BC will give us an expression for this BC, and then we need an expression for BD, because that's also in this triangle here. Okay, so step 1, in triangle ABC. Sorry. In triangle ABC, we've got tan 12 degrees is equal to H over BC. Rearranging that, we get that BC is equal to H over tan 12 degrees. And because we know that 1 over tan is cot, we know that BC is H cot 12 degrees. Okay, we can do a similar thing for the second triangle. In triangle ABD, we've got tan 10 degrees is equal to H over BD. Rearranging BD, we get BD is H over tan 10. And because 1 over tan is cot, BD is equal to H cot 10 degrees. Okay, so we now have an expression for BC up here, which is H cot 12 degrees, and BD is H cot 10 degrees. Now we need to have a little bit of a look at our question above, because it tells us that we're looking to use 400 and the other two sides. So if you look at our triangle here, we've got a right angle triangle. We don't have any other angles, so we can't use sine, cos or tan. We've got three sides, so the sensible thing to do would be to use Pythagoras. So what that means is that we're going to get 400 squared is equal to the hypotenuse squared, so H squared cot squared 10 minus the shorter side squared, so H squared cot cot squared 12 degrees. That allows us on the right hand side to take out a common factor of H squared, leaving us with cot squared 10 minus cot squared 12. Getting H squared on its own, I'm just going to put the H squared on this side, so I'm just flipping the equation, and that gives me 400 squared all over cot squared 10 minus cot squared 12, and finally taking the square root, we should get H is 400 over the square root of cot squared 10 minus cot squared 12. Okay, which is the correct expression. The only difference is that they've written it, instead of with the square root, they've written it with a power of half, and because it's on the bottom, it would be to the power of negative half. So you should just finish your question writing it the way that they do. Okay, so that's the major part of the question. It then says, hence find the height of the mast to the nearest metre. So what we need to do there is use our calculator to find the final answer. Okay, so remember on your calculator that you need to use tan instead of cot. Alright, so 1 over tan 10 degrees squared minus, minus 1 over tan 12 degrees squared. Okay, and that is then to the power of negative half. Just put that in brackets to make sure that you've got the correct power. Okay, so we should get 126 to the nearest metre. Always make sure at the end that your answer makes sense as well. Okay, so 126 metres makes sense for this particular question, because we're looking at a distance here of 400 metres, so relative to that, 126 makes sense.